the definitions of the trig functions in terms of x, y, and r. Today we're talking more about how they are related to each other. We know that sine and which function are reciprocals of one another? Cosecant. Tangent and cotangent, cosine and secant. I gave that away. So this just tells you what that means in terms of reciprocals. If you have, if I have sine, that's the same as 1 divided by cosecant. Or cosecant is 1 divided by sine. It works both ways. Essentially, all that's saying is if you have one trig function, you can automatically get its reciprocal by flipping it. So if you don't want to write down this long thing, you can just make a note to yourself which ones are reciprocals. Sine and cosecant, cosine and secant, tangent and cotangent. That might be more beneficial to you rather than like the definitions given in the book, because we know what reciprocals mean. If you have one, you just flip it to get the second one. So you really just have to know which ones go together there. Something I want to caution you on. In algebra, negative exponents are what tell us to flip. But in trig, when you see sine to the -1, that does not mean 1 over sine. This actually has a different meaning. It's talking about inverse functions. We will look at those more later on. But on your calculator, you'll notice you don't have buttons for all 6 trig functions. If you look at your calculator, it has a sine, cosine, and tangent. Above those, it has sine to the -1, cosine to the -1, tangent to the -1. Don't use those -1 buttons right now. We haven't talked about what they mean. If I have sine and I want to get cosecant on my calculator, I would type in 1 divided by whatever my sine is. Don't use the -1 powers. So let's look at a couple examples involving our reciprocal functions. I want to find each of these values. Okay, so I want tangent of theta given that cotangent is 4. So if I know cotangent is 4, what is tangent going to be? Right. I know, you don't necessarily have to write this, but I know that tangent is 1 over cotangent. So tangent of theta is just 1/4. Again, if at all possible, let's stick with fractions and lowest terms. Don't give me decimals unless it can't be avoided. Questions? Right, second one. I want secant of theta if cosine is -2 over radical 20. We know secant and cosine are reciprocals. So to find secant, you just have to flip this. Would I leave my final answer like this? What could I do? Radical 20 could break into a 4 and 5. Square root of 4 is 2. And those -2's will drop. So secant of theta is actually just negative radical 5. Even though the original one, I didn't give it to you in reduced form, I do still expect you to reduce your final answer as much as possible. Questions, sir? Next thing I want to talk about is the signs of our function values. You guys had a section on that homework where it would give you a quadrant and it would tell you x over r or y over r, and you had to tell if it would be positive or negative. In general, we can figure out when our functions are going to be positive and negative. We know that r is positive no matter what. If I took a point in the first quadrant, is the x value positive or negative? Positive, and the y value is positive. Okay, so sine is x over r. So positive over positive is positive. Sorry, I said sine, didn't I? Cosine is x over r, so that's positive. Sine is y over r, so positive over positive is positive. Tangent is y over x. So what's true about all of those? Positives. And we know the reciprocal will have the same sign. So in quadrant 1, they are all positive. All 6 trig functions turn out to be positive if your angle lies in the first quadrant. In quadrant 2, if you took a point, the x value would be negative and the y would be positive. So would sine be positive or negative? Positive. Sine is y over r, so positive over positive. Cosine, though, would be negative. X over r would be negative. Tangent, y over x, would be negative. So in quadrant 2, sine, and it's reciprocal because they match, and cosecant are positive. The other 4 functions turn out to be negative. In quadrant 3, if I take a point in quadrant 3, the x value is negative, the y value is, so if you do sine y over r, that would be negative. Cosine x over r would be negative. Tangent y over x would be positive. So tangent and its reciprocal, cotangent, are positive in quadrant 3. The other 4 are negative. Everybody understand how I'm doing this? Okay, let's look at quadrant 4. If I take a point, the x is positive and y is negative. So sine y over r would be negative. Cosine x over r would be positive. Tangent y over x would be negative. So that means cosine and its reciprocal, secant, are positive. So here's a trick to help you. All students take calculus. In quadrant 1, they are all positive. In quadrant 2, sine is positive, so it's reciprocal. T, quadrant 3, tangent and cotangent. Quadrant 4 is cosine. So all students take calculus. It tells you when they are positive, and so then the others would be negative. In quadrant 1, everything's positive. Quadrant 2, it's sine. Quadrant 3, tangent. Quadrant 4, cosine. guys understand that trick that I'm talking about in a second. So this is another huge piece we will be using as we move forward. It's never really going to go away. We're always going to have to be able to figure out if things are positive or negative. And we can just use this trick to help us. Okay. So let's look at an example. I want to determine the sign, so I'm just asking positive or negative for an angle in standard position with these measures. So 54 degrees, what quadrant is 54 degrees in? Quadrant 1, because that's between 0 and 90. Okay, so in quadrant 1, we're thinking all students take calculus. In quadrant 1, all 6 functions will be positive. Quadrant, or letter B, 260 degrees. What quadrant is that? We have 0, 90, 180, 270. It's between 180 and 270, so that's quadrant 3. Okay, in quadrant 3, T is for tangent. So tangent, and if you have tangent, the other is cotangent. Those are positive. So that means the remaining 4 functions, sine, cosine, secant, and cosecant, are all negative. C, negative 60. What quadrant would negative 60 be in? And negative just spins down, so that's quadrant 4. If you weren't sure, you could also add 360. You get 300, which is between 270 and 360, so that's quadrant 4. In quadrant 4, C is for cosine, and its reciprocal secant. So those 2 would be positive, and the other 4 are negative. Does that make sense to everybody? Ask some more questions about the signs of these things. I'm going to give you a requirement, and we are going to pick which quadrant we need to be in. And it could be more than one. So identify the quadrant or quadrants that satisfies these conditions. So find the quadrant. Part A. Tangent of theta is greater than 0. Cosecant of theta is less than 0. So we're just doing our all students take calculus. Greater than 0 means positive. In which quadrants is tangent positive? 1 and 3. All the trig functions are positive in 2 quadrants and negative in 2 quadrants. So tangent's greater than 0 if you're in quadrant 1 or quadrant 3. Okay. I said cosecant is less than 0, so that means negative. If I'm talking about cosecant, what trig function am I thinking about? What's its reciprocal? sine. Okay, we know in quadrant 1, everything's positive. In quadrant 2, sine is positive. So it's negative in 3 and 4. So in which quadrant are both of these things true? Quadrant 3. It's the only quadrant where tangent is positive and cosecant is negative. Why don't you guys try B? This tells me sine of theta is greater than 0. So that means positive. When is sine positive? 1 and 2. Cosecant theta is greater than 0. That means positive. Cosecant's the reciprocal of sine, so when is it positive? 1 and 2. So what's my answer? What quadrants can we be in? Yep. They're reciprocals. They always do the same thing. So this one actually had 2 possible quadrants that met the requirements. Okay. Is that all right with everything? The next piece I want to talk about is the range of the trig functions. What kinds of values can we get out? You know, you saw in your homework we got lots of fractions, we've gotten zeros and ones and undefineds, but what are the possible answers? In this, some of the trig functions behave the same. Sine and cosine actually have the same range, as do tangent and cotangent, and secant and cosecant match up. So they kind of look very similar. Sine goes with cosine in terms of what the possible values are. The easiest way to make sense of the range is, I think, to think about a triangle. This would be our x, our y, and our r. If you are talking about sine, what's the definition of sine? Y over r. If you're looking at a triangle, what's the longest side in this? R. So if I'm doing y divided by r, I'm taking y and dividing by something bigger than it, so I should get a number smaller than 1, right? Same thing is true if you're talking about cosine. X over r. R is still bigger, so you should get something smaller than 1. Now we just got done talking about how you could get negatives if you were in different quadrants. And we know from our table, if you land on an x or y axis, is it possible for sine to equal a positive 1 or a negative 1? Look at your table from yesterday. Did we get positive 1, negative 1 for sine values? Did we ever get 0? Yes. Sine and cosine can actually equal anything in between negative 1 and positive 1. 1 and negative 1 only happen if you land on an x or y axis. Otherwise, it's numbers smaller than 1 because it's x or y divided by r, and r is the biggest side. In terms of tangent and cotangent, is there any rule about whether x or y is bigger? No. I could draw a triangle like this. I could draw one like this, couldn't I? So x and y could be anything. Tangent, remember, is y over x. Cotangent, x over y. If those numbers can be anything, that means when you divide them, you can get any answer. So tangent and cotangent can be anything. Secant and cosecant. Okay, secant. That's r divided by x. So if you take a number and divide by something smaller than it, what kind of answer do you get out? Bigger than 1. Okay, same thing with cosecant. R over y. You're going to get something bigger than 1. Could be positive or negative depending on the quadrant. Can also be positive or negative 1 if you're landing on an axis. So essentially cosecant and secant are the opposite of sine and cosine. You can get everything smaller than -1 and everything bigger than +1. You're just not getting numbers in between 1 and -1. Now, we will look at this a lot more later on, especially when we get to graphing our trig functions. This is just kind of the first time you're introduced to it, but it is most certainly not going to be the last. We will keep talking about this and making a little more sense of it as we go. So, using this information, I'm going to put a few problems up here, and I want you to decide if these are possible or not. So you know what kinds of values sine and cosine and so forth can equal. So would it be possible for each of these trig functions to happen? So can cotangent equal -0.999? Yeah, tangent and cotangent can be anything, so that's possible. Can cosine equal -1.7? No, it can only be things between -1 and 1. Can cosecant equal 0? No, it can't be anything between -1 and 1. I'm going to put one more up here. Is it possible can sine equal -4/5? Yes. Can cosecant equal 5/4? Why? Okay. Cosecant has to be bigger than 1 or smaller than -1. So the 5/4 itself isn't a problem. If that's all I gave you, can cosecant equal 5/4? Yes. But this is overall not possible. Why?
They're reciprocal.
Right, they're reciprocals. If sine is -4/5, cosecant would have to be -5/4. So while it's okay for cosecant to be 5/4 and it's okay to for sine to be -4/5, they can't be different values at the same time. If one of them's negative, the other one would have to be negative because they have to be reciprocal. Angle theta is in quadrant 3, and tangent theta is -8/5. Find the values of the other 5 trig functions. This problem, there are really 3 different ways we could solve it. 2 of the ways we've seen already. One way I'm going to show you in a second. We know how to find all 6 trig functions if we have an x, y, and r. So our first option would be to pick out x, y, and r and go from there. Some people really prefer to draw triangles in this scenario, so you could draw the triangle and use SOHCAHTOA if that helps you. So I'll probably put both options up here and you can kind of decide what you'd like. What is the definition of tangent? So that tells me right now the x would be 5 and the y would be 8. Okay, but something's wrong with that. We are in quadrant 3. If you're in quadrant 3, what's true about x and y? They're both negative. Why didn't I have negatives up here? Yeah, 2 negatives cancel each other out and make it positive. But you do have to pay attention to your quadrants now. So I have to use -5 and -8. Okay, now we can find our r. X squared plus y squared equals r squared. doesn't work out perfectly. 89 is not a perfect square. Is it divisible by any perfect squares? No, so we're just going to leave it as radical 89. Okay, now you have x, y, and r, and you can do your 6 trig functions. If you like triangles, then your triangle here, this is the -5, the -8, the radical 89, and you're going to look from that viewpoint and do SOHCAHTOA from there. So sine, what's the definition of sine? Y over r, so my y is -8 over radical 89, or -8, radical 89 over 8. Definition of cosine, x over r, so that's -5 over radical 89, multiplied by radical 89 on top and bottom. Tangent was already given to you. I just said give me the other 5, so you could list it again, but I'm not going to. Reciprocal of sine is cosecant, so that's my r over y, or if I just flip my sign, negative radical 89 over 8. Secant, r over x, or flip the cosine, negative radical 89 over 5. And cotangent, x over y, or just flip the original tangent, and you get 5 over 8. So I don't have to give you an ordered pair. I could give you one of the trig functions, and that's all the information you need to find the x, y, and r, and give me all the others. Questions on that? So I want to talk about some more identities today. Today's mostly going to be notes. I'm going to give you some work time tomorrow, but I want to try to get through this section if we can today. We have been using this x squared plus y squared equals r squared over and over again. We can actually relate this to our trig functions. If I went through and divided each of these things by r squared, we know in an equation if you do it to both sides it's legal. Then that's x over r squared. This is y over r squared equals 1. What is x over r? Cosine. Y over r is equals 1. This is what's called a Pythagorean identity. There are actually 3 of them. This is probably the single most important one. Cosine squared plus sine squared is equal to 1. Always. So when I give you a trig function, you could choose to use this formula to find the other one if you wanted. There are 2 others. If we go back to this x squared plus y squared equals r squared. Let's say if instead of dividing by r, I divided by x squared. And I have 1 plus y over x squared equals r over x squared. What's y over x? Tangent. What's r over x? So the second one is 1 plus tangent squared is equal to secant squared. How do you think we would get the third one? Divide by y squared. So we have x over y squared plus 1 equals r over y squared. X over y is cotangent. R over y is so that's the third one. Cotangent squared theta plus 1 equals cosecant squared theta. These are useful to know. In trade, we have a lot of formulas like these that come up, and so on most tests and quizzes, I am going to give you a formula sheet. These are actually on the formula sheet. I would really like it if you could maybe memorize the first one. That is the single most important one. That's the one that if you have to go on and take calculus or something, that's the one that keeps popping up throughout. But in general, I will give you the formula sheet that has all these on there. And we're not going to use them a whole lot yet. It'll come later on, but I just want to kind of show those to you now. All right, I'm going to do one more slide of definitions, and I'm going to do a couple of examples, and then we'll be done. Other identities. This one is not going to be on the formula sheet because it's important enough that I need you to just learn these. If I wanted to divide two functions, if I take sine divided by cosine, I want to know what that equals. If we're not sure, we can use our x, y, and r definitions. What's the definition of sine? Y over r. Definition of cosine is x over r. How do you divide fractions? Split and multiply. So the r's cancel. You're left with y over x, which is so what you need to know is tangent is equal to sine divided by cosine. Okay, I kind of showed you where it came from, but that is one that comes up a lot. So what would cotangent be equal to? Cosine over sine, because they're reciprocals. That is something we should know. I want to use these identities for maybe one example. We're more just going to be building off these identities in the weeks to come, but I want to kind of give you a taste of it now. Let's say I want you to use the identities to find sine theta and tangent theta if cosine theta is negative 7 over 25 in quadrant 2. could most certainly do this the way we did the last example, where we pick out X, Y, and R and go from there. This time I've asked you to use the identities just because I want to show you how those would be used here. So if I want to find sine, we know that cosine squared plus sine squared equals 1. That was one of the identities I gave you. So we could plug in the values. Cosine is negative 7 over 25 squared plus sine squared equals 1. If I square this, I get 49 over 625. Subtract that over. $5.76. Is that right? Somebody checking? Then what would you do to get sine? Square root. With a square root, we do plus and minus. However, we know we are in quadrant 2. In quadrant 2, sine is positive, so I would go with the positive answer. And what's the square root of 576 over 625? 24 over 25. If I have sine and cosine, how do I get tangent? Divide them. So we could do 24 25ths divided by negative 7 25ths. And what do you get? Make sure if you're using a calculator, you put this in parentheses. At this point, I don't really care how you find the answers as long as you keep. So I wanted to show you identities. Most people typically prefer either drawing the triangles or doing X, Y's, and R's, but these identities are certainly an option. What do you guys prefer? X, Y, and R's? I think I'm going to go ahead and stop here today. So the homework assignment, it looks worse than it is. It's like 1 T2, 23 problems. We are going to have class time tomorrow to work on this. So I've taught the whole section. I might do some review problems at the end of class tomorrow because I said we're going to have a quiz on Friday, so I'll probably do a little bit of review the last 10 minutes or so, but otherwise you will just have time to work on this.